Okay, let's get into it. Today we're diving headfirst into the real scaffolding of how big companies manage their code, their teams, their security.
We're going deep on GitLab Subgroups.
Exactly. And we're moving past the basics. You know, the simple GitLab group that just holds projects and people.
We are. We're zooming in on what the sources call, and I think this is a great analogy, the Russian nesting dolls of the GitLab world.
That nesting doll analogy is perfect. It just immediately makes you think about layers and structure.
It does.
But for
Anyone listening who's maybe running a leaner operation, the question is obvious. Why? Why add all this complexity? A basic group works just fine for a startup.
Yeah, that's a fair question.
why do we need to nest groups inside other groups? Why not just have one giant flat list?
It really comes down to two words, scale and context.
Okay.
I mean, once you have hundreds of projects, maybe thousands of users, a flat list it's just chaos. It becomes meaningless.
Right, you lose the ability to see what's what.
Completely. Think about it. If you see a team called security, what does that even mean in a flat list? Is that security for infrastructure, for the mobile app, for the European division?
Without the hierarchy, the label itself is useless. It has no context.
Exactly. And that is precisely why subgroups exist. They let you map your complex corporate structure right into the tool. You can create a path that just makes sense. It reads like an org chart.
Like company products, mobile app,
Yeah.
iOS team, that kind of thing.
That's the perfect example. Every one of those steps, from products on down, is its own subgroup. And suddenly every team, every project, it has a crystal clear address, a context.
So it's not just about being tidy. It's an architectural decision. It defines the boundaries for everyone.
It is.
That sounds like a system designed for, well, almost unlimited scale.
Yeah.
How deep can you actually go with this? Is there a technical limit?
There is, and this is a really key detail for anyone planning architecture. GitLab lets you nest subgroups up to 20 levels deep.
20 levels. Wow,
Yeah.
it's a huge capacity.
It is. Most companies, even the big multinationals, they barely get past 6 or 7 layers in their real org chart.
So what does a 20-level ceiling tell us? Is that just a technical number, or is it for some kind of, I don't know, super distributed microservice architecture?
It's probably a bit of both, but in practical terms, it signals that the system can handle extremely granular organization. You could have, say, 10 levels for your company structure, another 5 for the product line, and the last 5 for individual microservices.
I see.
The system lets you define context all the way down, and that depth, that number is so critical because it directly controlled how access is managed.
That makes perfect sense.
Yeah.
The structure isn't just a filing system, it's the rule book.
Exactly.
So let's go there next. Let's move from the where to the how. How do permissions actually work inside this deep 20-level hierarchy?
It's all managed through what the sources call the Waterfall Model.
The Waterfall Model.
And it's the core of permission management. The rule is simple. It's absolute. Permissions flow down, always. They never, ever flow up.
Okay, down, never up.
Yeah.
I like the clarity. But let's test that. Let's say I'm an owner at the very, very top, the company group.
Yeah.
What does that give me 3 levels down in the iOS team group?
If you're an owner at the top, you are automatically an owner of every single subgroup and project underneath it, all the way down to that 20th level.
And the people at the lower levels can't. They can't kick me out.
They cannot block you. That's the key. You are the inherent authority over that entire structure below you. It's designed that way, so oversight can't be fractured, either accidentally or, maliciously.
Okay, that establishes clear authority. But now the flip side, which is just as important, granular control. We hire a contractor.
Yep.
They only need access to the iOS team code. We absolutely cannot have them seeing the company's strategic roadmap or anything higher up. How do we isolate them so perfectly?
And this is where the design really shines. It's kind of beautiful, actually. You just add that contractor to that one subgroup, the iOS team.
And that's it.
That's it. The key is that their visibility is confined to the namespace where they were added.
So, explain that a little more. They're not just restricted, they're actually blind to the groups above them.
Precisely. Because permissions flow down, not up. If you're only a member at level 4, you can see everything at level 4 and below. But you are completely outside the scope of the groups above.
The product, company, they just don't exist for that user.
They don't even appear on their dashboard. You can't navigate to them.
The isolation is passive. It's a result of the structure, not some, manually configured security rule.
That's fascinating. It really means that if you plan the structure right from the beginning,
Permission management almost becomes an HR function. You add the person to the right specific team, and the system does the rest.
That's the goal. The sources call it passive governance, and if you get the structure right, they say permission management becomes almost zero effort.
Almost zero effort. I was hoping you'd catch that. That sounds a little too good to be true.
It is.
Where does the effort actually go?
It all goes into the initial planning. It's only zero effort after you've done that huge intellectual lift of designing the hierarchy correctly from day one. Because the cost of fixing a structural mistake 5 years later, realizing, the product group should have been split into internal and external, that cost is enormous. The permissions are now baked into that structural debt.
So the implication is that initial planning carries the weight of all future security. If you mess up the first
3 levels.
You're signing up for years of headaches downstream. It's an absolute trade-off. Effort today for simplicity tomorrow.
Okay, that sets up our next topic perfectly. We've built this beautiful
full functional hierarchy, but things change, teams merge, projects get old, and suddenly we realize project X is in the wrong place. We need to move it.
And you can. GitLab has that flexibility. You can move a project into a different subgroup. You might take project X and say, tuck it into an archive subgroup just to clean up your main workspace.
This is where I feel like things could get tricky and maybe a little painful.
You're right to think that.
When I move a project, its path changes. It goes from, say, GitLab.com / company project X to GitLab.com company archives project X. What does that do to every developer who has that repository cloned on their machine?
And that is the single most critical operational hazard to be aware of. When you move a project, its namespace changes, the path changes, and that have immediate technical consequences.
I can almost hear the collective groan from developers getting that email. So why does the path change actually break things for them locally?
This is the deep dive distinction you need to have. Internally, GitLab is pretty smart. It can handle redirects for web traffic. So if someone clicks an old link in their browser,
GitLab will probably figure it out and send them to the new page.
Usually, yes. But that intelligence stops at the edge of their network. It does not reach the developer's laptop.
So the headache is the local configuration.
It is. When you clone a repo, your local git config file, specifically .gitconfig, has a literal hard-coded path to the remote origin. It has that old URL written right in it.
So when they run a git pull,
the local system tries to call that old address, which now points to nothing. The command just fails.
And GitLab's server redirect can't. It can't magically reach into a developer's machine and rewrite that file for them.
Exactly. So for all local Git operations, pulling, pushing, cloning developers will have to manually update their remote URL. You have to communicate that change, and you have to do it clearly.
That is a huge piece of information. It shifts the responsibility from just being a platform feature to being a communication challenge. You have to factor in that developer friction.
You do.
Are there ways to mitigate that, though? Can you use SSH remotes or something to make the paths more stable?
Absolutely. Moving to SSH remotes is a common strategy. The SSH path is often a little simpler, a bit more resilient, but really the best practice is to abstract that path away from the developer entirely. Through things like standardized environment variables in your build scripts. If the path is stored in one central place that's easy to update, the impact is minimized.
That is the kind of practical tip that saves weeks of support tickets. Okay, so use subgroups for organization, rely on the waterfall model for permissions, but be really, really careful when moving projects.
Because you're changing the address. And that requires a manual fix on the developer's end, or some clever architecture to begin with. The difference between streamlined control and total chaos is often just knowing what's happening inside that little .gitconfig file.
So what does this all mean for you? We started by establishing that subgroups are the architecture for scale, with a huge 20-level capacity.
Then we learned that the key to security is the waterfall model. Permissions flow strictly down, giving you that passive governance if you plan it right.
And finally, we hit on that critical operational hazard. Moving a project is fine for the web, but for local Git operations, developers have to manually update their remote URL to point to the new namespace.
And all of that hinges on the quality of your initial design. That first decision about how to structure your groups, it sets your security model for years, maybe a decade.
It does. And that brings us to the final thought we want to leave you with, something to really think about.
If an organization has 20 levels of nesting available and permissions are inherited strictly top-down, so the structure is the security model, what hidden costs emerge 5 years from now if that initial top-level organizational structure turns out to be only, say, 70% accurate?
The long-term impact of that structural debt, realizing architectural decisions today become permission mandates tomorrow. A great place to end this deep
Dive. Thanks for joining us, and we'll catch you on the next one.